Hello friends, how are you? I hope you are well. Today's study plants the seed for tomorrow's exam success. That means if you are studying today, you are planting the seeds for your success in exam. So children, without delaying, it is better to start the lesson and I hope that you might have subscribed, but don't forget to comment on my video. Let us start. Generally, in a summer season, we prefer to take cold food, whereas in winter season, we prefer to take hot food. Especially I like to take hot coffee, hot tea, hot food, everything we prefer to take hot during winter, during cold. Whereas in summer we prefer to take cold food. But one problem is there. What problem? In summer, the food takes more time to become cool if it is the hot food. At the same time, in winter, the food what we are going to take, if we have taken hot also, towards the end it is becoming very cool. The real fact is that in winter, the rate of cooling is faster than summer. So, what is the reason behind it? We will discuss through Newton's law of cooling. So, today's topic is Newton's law of cooling. See here, suppose this is hot milk. We have taken a cup of hot milk. If it is placed on a table, after some times we are finding that its temperature decreased. That means from hot it became cool. What is the result? So, the reason is very clear that there is a exchange of heat between the hot milk and the surroundings. There is an exchange of heat between the hot milk and the surroundings. The fact is that there is a difference between the temperature of hot milk and the surrounding air. So already we have discussed net heat transfer from body of higher temperature to body of lower temperature. Here heat loss to the surrounding by the process of radiation. That matter we are going to discuss through the Newton's law of cooling. But the question comes that how fast it becomes cool. I said in the starting, summer season it takes more time, whereas winter season it takes less time to cool. So today's topic is the rate of cooling. Mainly we will discuss about the rate of cooling. So definitely it will be cool, no doubt at all. But how fast or how slow the temperature is changing? To know that, let us see one small activity. For example, you think this is a calorimeter. In this calorimeter, you have taken one stirrer and you have placed one thermometer with a suitable hole. This is the thermometer. Now this calorimeter is closed with a double valve. There is no chance of escaping the heat or entering the heat into the container. Okay? Suppose you have taken some water. Think that you have taken 500 milliliter of water. Now the thermometer is placed in water. You observe the reading of the thermometer. For example, the thermometer reading is T1. That means T1 is the atmospheric temperature. This is the thermometer reading T1. This is the atmospheric temperature. Now you allow the water to heat. Suppose the temperature of the water reached around 40 degrees Celsius. You can stop heating. Suppose this temperature of water, temperature of hot water, you think this is now T2. So definitely this T2 greater than T1. Now start stopwatch. Record the temperature after regular intervals. For example, after each 30 seconds or 1 minute gap, you try to note down the temperature and note down the time also. For example, now the temperature is 40 degrees Celsius. After a minute, it will not be 40 degree. Definitely there will be a difference in temperature. So, suppose now the temperature is T2, surrounding temperature is T1. That means the difference in temperature is T2 minus T1. So, after each equal interval, 1 minute interval, you note down the difference in temperature and also record the time. So, you will find that ultimately one stage will come where the temperature of hot water inside the container, now what is hot, will be equal to surrounding temperature. Ultimately both temperature will come same. But before reaching that temperature, suppose the surrounding temperature is 5 degree. Now the inside temperature reached 10 degree. At that time you can stop the observation. That means from 40 degree to 10 degree Celsius, each 1 minute you have to record the change in temperature as well as the time. That means I want to say that here the temperature will comes down, no doubt at all. Temperature will comes down because there is an exchange of heat energy between the hot water inside the calorimeter and the surrounding atmosphere, and this exchange of heat became possible due to difference in temperature only. If there is no difference in temperature, there will be no transfer of heat energy. So the important fact is that there is a difference in temperature between the surrounding and the water inside this calorimeter. Okay. Similarly, in case of the hot coffee, if you have taken, you will find that after some times the temperature came down. With the passage of time, temperature coming down. That means it is getting cool. But the thing is that here we will discuss the rate of cooling. If I draw a graph by taking the difference in temperature against the time, for example, in the x-axis I am taking time, in the y-axis I am taking delta T, difference in temperature. So here you can write T2 minus T1. I have taken the y-axis, time in x-axis. You will find that the graph will be like this. You observe the graph. From the graph, what we are understanding? We are understanding that from the beginning, the rate of falling the temperature very fast. You see this is the time gap. This is the time gap. But falling temperature temperature here to here. This one shows the fall in height of fall in temperature. This one showing the time. You come here, for example, here to here. You will find only little less in temperature where the time has taken more. That means in the beginning, difference of temperature between the water inside the enclosed container and the outside was more. Difference in the beginning was more. Towards the end of the observation, difference is decreasing. Suppose 50 degree to 50 degree, it came to 10 degree. Difference is decreasing. Suppose 50 degree is the water temperature. Atmospheric temperature is 5 degree. Okay. Now we came. Suppose this is 10 degree. This is 5 degree. Here the gap is 45. Where here the gap is 5 degree. So when the difference in temperature is more, the rate of a cooling is more. When the difference in temperature is less, rate of cooling is less. This is the time. This height represents the rate of cooling. The temperature comes down. Here suddenly the temperature came down because the difference in temperature was more. So this was observed by a famous scientist. This is none other than our beloved Newton. So Newton systematically observed. What he observed? The relation between heat transfer and the temperature. Relation between heat transfer and temperature. It was systematically observed by Newton. Let us see here the rate of cooling. I can say the rate of cooling. Suppose dQ is the heat, dt is the time. I have taken small dQ by dt. Rate of cooling, I can say this is the rate of cooling. This rate of cooling is directly proportional to change in temperature. Listen carefully. This rate of cooling is directly proportional to change in temperature. That means how much more the difference in temperature, that much cooling will be fast. So I wrote the rate of cooling. This is the rate of cooling directly proportional to change in temperature. But physics will not understand the language of cooling. So for that purposes, in place of rate of cooling, we use loss of heat energy. We use loss of heat energy. So I can say that loss of heat energy is directly proportional to change in temperature. So dQ upon dt, this is the loss of heat energy. So I can write here minus dQ by dt directly proportional to T2 minus T1. Why I have written the minus symbol? The reason is that the system is losing the heat energy. That's why I mentioned minus dQ by dt directly proportional to T2 minus T1. If I remove this proportionality symbol, I shall use here Q upon dt is equal to K into T2 minus T1. So this K is called constant, but this constant value depends upon the nature of the area. Suppose this is the container where we have taken the hot substance. How the shape of the container, how much surface area of the container exposed to the atmosphere, K depends upon it. For example, you see, you have taken hot substance in a plate and same hot substance in a cylindrical surface. Here the amount of surface exposed is more than here. So here it will become cool. So this K value depends upon the surface area exposed and also how the surface of the shape of the substance. For example, I said that one substance is like this, one substance is like this. Same volume may be, same mass may be, but the surface is different here. So the K value depends upon the surface area. How it depends upon? Okay, K value depends upon the surface area. So thou it is a constant, but it is differing from one substance to another substance depending upon the place where it is taken. So K is a constant of proportionality, and this one is the Newton's law of cooling. See here. In this case, suppose this is the equation 1. I mentioned the equation 1. So, whenever the substance losing the heat energy in the form of the radiation, we know that this Newton's law is valid. It is good if the temperature difference is very less. For example, it is losing heat energy, but it is losing very less amount of heat energy. That means you can think that there is no change in temperature. So I said that Newton's law of cooling hold good for very less difference in temperature. So suppose the small amount of heat lost, that is equal to dq. dq is the small amount of heat lost, and suppose the mass of the substance is m, its specific heat is S, and the small change in temperature, that is dT. We know that heat formula. Heat is the product of mass, specific heat and temperature. Here dQ stands for small amount of heat energy lost. M is the mass of the substance. You can think that the water what we took inside the calorimeter in my previous example. dT is the small change in temperature. So now I can say that this dQ upon dt, I am taking reference system, is equal to ms dt upon dt. This capital T represents the temperature, whereas the small t represents the time. So I got that dq by dt is equal to ms dt by dt. So I can mention this is as the second equation. Clear? Now let us see. So if I put the value of dq by dt equal to ms dt by dt in equation 1, okay? So put dq upon dt is equal to ms dt in equation 1. In equation 1 we will put that value. So in place of minus dq by dt, I shall write, so here I am writing minus ms dt upon dt is equal to k into t2 minus t1. Okay, implies that I'm writing dt divided by t2 minus t1 is equal to minus k upon ms dt. See here, this k is a constant, m is a constant in the mass, S is the specific heat of the substance, it is also constant. That means this total I can consider as a constant. Then I can write dt upon t2 minus t1 is equal to minus, I am using capital K, dt. Here capital K stands for k upon ms. This total is constant, so I have mentioned like this. Now if I take integration, then I shall write dt upon t2 minus t1 is equal to minus k is a constant dt. So this is a indefinite integration, so I can write that this is the log, natural log t2 minus t1 is equal to minus kt plus c. Listen carefully. I have written kt because this is a constant integration of dt, t plus c. Why I have written? Because it is a indefinite integration. So this c stands for the integration constant, or I can mention that this t2 minus t1 is equal to e to the power minus k into t plus c. So here I am rubbing. Implies that, so e to the power minus kt plus c, or I can write this t2 minus t1 is equal to e to the power minus kt into e to the power c. Here c is a constant, e is also constant. So this total e to the power c, this is also a constant. So I can write that this t2 minus t1 is equal to e to the power minus kt into c dash. Here I have taken since c dash is equal to e to the power c, or I can say that this t2 is equal to t1 plus e to the power minus kt into c dash. So from this formula, by this formula easily we can calculate the time of cooling. So this is about the Newton's law of cooling. From this, by this formula we can calculate the time of cooling. So the Newton's law of cooling, we understood about the rate of cooling of a substance. So the next concept is about the greenhouse effect. So I hope that you know, still I shall remind you what is the greenhouse effect. What you might have learned in your lower classes, also you might have studied in high school level in social study. So greenhouse effect. greenhouse effect. You know that the 75% of the sunlight coming towards the earth or the light what is coming from the sun towards the earth, about 75% received by the earth. At the same time, some other components, that means we say greenhouse gases, the heat absorbed by the earth, again earth emit it, but the fact is that the greenhouse gases like the carbon dioxide, nitrous oxide, chlorofluorocarbons, even the water vapor also absorbs some extent of heat energy, which keeps our atmosphere warmer. The heat what is absorbed by the earth, it emits by radiation. But these gases absorb some extent of energy, including the ozone layers. So it makes the temperature surrounding the earth comparatively more warmer. Then what happens? Time to time, climate is changing, temperature is increasing. This effect we say greenhouse effect. Why do we say greenhouse effect? Because in cold regions they develop some green plants inside the glass house. Cold region, what they do? They develop green plants. Okay, inside the glass house. The glass house made in such a manner heat can enter, but same amount of heat will not come out. That means inside the room, the arrangement made in such a manner, it will be more warmer than the surrounding atmosphere. As a result, some plants can survive. That's why we say that is the greenhouse effect. But this greenhouse effect also having some advantages as well as disadvantages. What is the advantages? If these greenhouse gases were not there, the earth would have been reached at the temperature of minus 18 degrees Celsius. Today, the temperature what is there? For example, at this place, today temperature 23 degree. But you imagine that if these greenhouses were not there, the temperature might have reached at minus 18 degree Celsius, which is very difficult for us to survive in this cold region. So these are the advantages as well as disadvantages. What are the disadvantages? Disadvantages that the ice caps, due to increase in temperature, ice caps are melting. The level of sea water is increasing. The countries like India, like Indonesia, like the Maldives, there is a fear because some part of India, coastal belt, their water level is increasing. There is a chance one day it will be submerged in water. So this is the time we have to think about our climate, about your atmosphere. We have to take the care. So many voluntary agencies have taken some initiative to control the greenhouse effect. We have to control greenhouse effect, we have to take different measures, like we have to use less number of automobile vehicles, because among the greenhouse gases, carbon dioxide is about 50%. So it comes more from the vehicles, and we are sometimes burning unnecessary the firewood. So we have to control it. We have to decrease the burning of firewood. We have to use the less automobiles as much as possible. We have to do the plantation to protect our mother, the earth. So I hope that you might have understood today's concept. So next video, most probably I shall explain some numerical problems. Thank you.